Hey there guys, welcome back. Our today's problem is power of a number. We have to take base and exponent from the user and we have to print the power of that number. Print wrong input if the value of the exponent is negative. Our first line of input contains base and the second line of input contains exponent. And our output should be the power of that number. So if our base is minus 3 and the exponent is 3, then our output should be minus 27. Because here base is minus 3 and its power is 3, so minus 3 to the power 3 means minus 3 cube is minus 27. So we have to print the power of that number. So let's see in code. I have the class power and I have created a method static void power and it takes two arguments, int base and int exponent. Then I'll initialize a variable power to store power of the base. So int power is equal to 1. So I'll use for loop for int I is equal to 0, I less than exponent I plus plus power into equal to base. We are multiplying base each time and we are storing the result in power. Here what we are doing is, we know that for finding power of any number, we have to multiply the number that number of times. So here we will multiply base by base, but we have to store the previously multiplied values somewhere. So let's see with the help of an example. Suppose we have an array and we have to find the sum of that array. Let's say array is 1, 2, 3. So we will first initialize a variable to store sum. So sum equal to, we will initialize it with 0. Here we will start with first element of the array. So sum plus 1 equal to 1 and we will store this value in sum variable. Then we will add next element of array with sum. So sum plus 2 equal to 3 and we will store 3 in sum. Now we'll add third element. So sum plus 3 equal to, sum is currently 3, so 3 plus 3 is 6. So now we'll store 6 in sum variable. Similarly for power, if we have 3 to the power 3, that is 3 cube, then we'll initialize a variable power equal to 1. Why equal to 1? Because multiplying any number with 1 will not affect that number. Similarly in sum, adding 0 to any element will not affect that number. So that's why in sum we'll take 0 and in power we'll take 1. And at each iteration we'll multiply power and base. So power is currently 1 and we'll multiply it by 3. So we have 3 into 3 into 3. So we'll take first 3. So power into 3 is equal to 3 and we'll store this 3 in power. Now power into 3 is, power is currently 3 and 3 into 3 is 9. So power will become 9. And now power into 3 again. So power is 9 and 9 into 3 is 27. So we'll store 27 in power. And now we have multiplied 3 times. So this is our result. So 3 cube is equal to 27. So here we are doing power is equal to power into base. Okay. And we'll print power. So system.out.println power. And also if our exponent is negative, then we have to print wrong input. So we'll check this condition before using for loop. So if exponent is less than 0, then system.out.println wrong input. and will return immediately. Okay, in that case we'll not go into for loop. Now let's see the driver code. I'll use scanner class for taking the input. Scanner sc is equal to new scanner system.in, and first I'll take base, so int base is equal to sc.nextInt, then exponent, int exponent is equal to sc.nextInt, and then I'll call power, so power base comma exponent, and import scanner class, import java.util.scanner. Now let's see this code. First I'll compile this javac power.java. Look, the code is compiled successfully. Now let's check for few test cases. Java power, let's say our base is 2 and exponent is 10. So 2 to the power 10 is 1024. So let's see. Okay, we are getting 1024. Let's check for one more time. This time our base is -3 and exponent is 3. So -3 to the power 3 is -27. Okay, we are getting -27. Let's check for wrong input. Let's say our base is 9 and its power is -2. Okay, we are getting wrong input. Okay, so test cases are working fine. There is a function in Java that is math.pow, which is used to calculate the power of any number. So here we can directly use it, but it's better if you define your own function. Okay, so that's it for this video. We'll see more problems in the further videos. Thank you.